So beforehand you can see that this is a simple structure, and we have given the external girth, the external diameter is 20,000 by 20,000, which is 20 meter by 20 meter. These are external girths. And you already know when it comes to taking off, we have to actually calculate the center line, center girth, as well as the internal girth. Right. So for the floor pan, there should be some correction in the floor pan. You can see our split concrete. There's no split concrete here. We have the plinth wall, which is made out of concrete, and it has a height of 400 millimeters. And you can see actually the plinth wall is consists of bricks actually up to here, the brick wall. This is a one section of the substructure, and you can see the ground level is somewhere in here. Then after the brick wall, we have a DPC layer. Then we have the bricks. In the internal structure, you can see there's a earth filling of 200 millimeters, and above that 100 millimeter concrete. We will take off these quantities and place it on a TDS sheet. First of all, it's better to write down this, but there's a small correction in here. The height from the ground level to the bottom of the trench, it should be 1,200, 100, 1,000, 1,200 millimeters. This 1,200 is incorrect. Okay. Then I will repeat the correction here. From the ground level to the bottom of the trench, it should be 1,200 millimeters, not like this. Okay. And now all the other drawings are, all the other dimensions are. So you can draw this one quickly. I will use like 2 minutes. So I hope you can see the screen as well, the whiteboard. So from the ground level, there should be correction from the ground level to the bottom of the trench. It is 1.2 meters. The width of the trench is 600 millimeters, 0.6 meters. Now we will move back to the taking off field. There are some specifications as well in this case. I'll show you the specifications. So you can quickly note this one down as well. Note this one down as well, please. So in the specification note, the size of the site is 40 meter by 40 meter, and there are some trees to be removed as well. With the different girths, you can see 1.3 meter girth is the perimeter of the tree. There are 3 number of mango trees, and there are 1 jack tree with 0.8 meter girth. And in third fact, they say excavate topsoil to an average depth of 150 millimeter and deposit on site for reuse. You can see it's also important. We have to dispose it on the site, not off the site, but on the site for reusing purposes. They are reusing the same stuff, right? Again, the fourth fact, all additional excavated material to be disposed off-site 4 kilometers from excavation. That's the one on the specification as well. For the concrete, 1 to 4 is 40 millimeter maximum size FBA. We are using engineering bricks and they have given specifications and what kind of bond they have to use as well. So the motor and for the DPC dam proof force, it retains the water enter into the our structure from the soil. The hardcore bed is lined with the sand and there's a DPM there as well. So I will move back to the taking off sheet, our taking off sheet. So from the start, you can see that's a little bit of a description on top of the PDA sheet. The project name is Classroom 1, NVDA Ramadan, program number, and name of the takeoff. So name of the takeoff is your name should be there. And what is the date? So before always taking preparing a PDA sheet, if we are taking off anything, it's better to make a takeoff list first. Otherwise, it might be confusing us. What is the next detail we have to put? So like that. So in that case, we can write down a takeoff list like this. We say starting from the site operation, skeleton of soil, disposal of the material, skeleton painter, and we have to backfill the trenches as well. So before constructing anything on the trenches, we have to support. And naturally, the earthwork support should be there and the formwork, maybe the extreme load, wood formworks. Then before starting the foundation, construction of the foundation, we can compact the trench as well. If there is any water, if we disrupt any water table, then we can dispose the surface water as well. Then starting from the concrete foundation, we can backfill that after the concrete foundation, we can backfill some of them. Then we can dispose of the skeleton material from previous part. Then we can start the flint board. Here it is a brick made out of brick. So that's a brickwork as well. Then we can backfill another layer, soil layer. Then again. And disposal of extracted material in any dam to both the hardcore bed and the concrete bed. So this is the taking of this. Please write down this one as well on your paper. So our first takeoff should be about site preparation, right? We can see in the specification note, they say size of the site is 40 meters by 40 meters. Then, if our first takeoff should be from the site preparation, we already know in the SLS 573, we have to go to the site preparation. So if I ask what section we have this procedure. It is in the section D, right? Here's my SLS tree. Under the section D, you can see site preparation, which is, I told you earlier, we can refer this one using number system. D, this we are referring to the first point, is D1, site preparation. There I am going with the clearing site vegetation. So it is D1, 1, and I have to provide sufficient instruction for this identification. And it should be square meters. It should be square meters. And under the definitions, you can write down site vegetation is whether it is bushes, trunks, undergrowth edges, or any stumps more than 500 millimeters in girth. And if you have any filling material, that should be also described as well. And actually, there's another point you can see under the site preparation. There's another thing, removing trees and stumps, because we have some trees with different girths. You have to go for these two as well, right? So in that case, I can write down our first introduction. So here you can see site preparation, clearing site vegetation consists of grass, bushes, and small trees, holes left by trees and bushes removal. To be backfilled with imported soil. So since in the you can see in this scenario, the part to be backfilled with imported soil. When you remove some small trees, there are holes left by those trees, right? Then we have to actually have a level ground, level reduced levels. In that case, we have to backfill those small holes as well. Actually, in the SLS 573, they are asking, you can see in here, filling material described. So it should be also described as well. It is not given us in the specification, but we should include that one as well. Then I can write down the point like this, site preparation, this introduction, and I can put some reference like this for my future reference, especially when you put this one on the abstract sheet and when you prepare the material as well. You can refer this one, this reference. This is the easiest reference. This is section D 1.1.1. Right? So you can write down this one. There is a small correction should be there. Once you write down the description, the relevant dimension should be put in this level. I mean, it's the end of the description. End of the description, our dimension should be there. So this part should be shifted to downside like this. I can write down that on the board as well. You can see the board. So here you can see under the TDS sheet, once you write down your description, the relevant dimension should be at the end of the description. So Since our site is 40 meter by 40 meter, I can write down 40 meter. So there should be always 2 decimal points there. Then I can get the then I can write down the total value like this. Right. So note down as well as that one as well, it will be always at the bottom line of the distribution. So relevant calculation. The line. So I hope you got the point there. Then I will move back to again to the slides. Okay. So our first taking of this is okay. The first part is okay, and you can write down your reference as well. So it is your future reference for your easement. Then, so in this specification now, there were some problems you see. There are some definitions about there are some trees to be removed, right? So in that case, we have to include that one to our taking of this TDS sheet as well. So if I move back to the relevant SLS tree, you can see what should be the reference for this one. So site preparation, it is 1. Removing trees and stumps, it is B1.2. And there are girths, there are girths between 1 meter to 0.5 meter, as well as more than 0.5 meters as well. So I think if I look at the girths, they are, when I move back to the specifications, you can refer your specifications that case. It is 1.3 meter, 0.8 meters. Both of them are they included in one section, or there should be 2 separate sections? What do you think? So you can see one tree has a girth of 0.8. So it should be going with this one. And another one is 1.3 meter in girth. So that should be going with the second one. Right. So you can see what do you mean by that? They are applying 500 millimeter stages. They are applying 500 millimeter in stages. So that means the next should be from, if it is the first one should be from 0.5 to 1 meter, the second one should be from 1 meter to 1.5 meter. Third one 1.5 meter to 2 meter. 2 meter to 2.5. Like 0.5 meter is stages. It means 500 millimeter in stages. So 1.3 is going with this stage, right? 1 meter to 1.5 meters. Right. If you get the point, so how to write down that one in that one on our take-off list? You can see again in here. So this you can see the reference you get like D1. Again, site preparation, removing trees and stumps like that. You have to write down this description. Some part of the description again to the second take-off forward. But in quantity surveying, we are using several abbreviations to save our time. So here you can see the ditto means do. The same descriptions as above, like that. Ditto means this description is referring to this description, but removing distance down to the 500 millimeter less than 1 meter. So there are only one free like that. One. And again, I have write down another description because there are 3 other trees. You can see here there are 3 other trees. Description 1.3 meter. There are 3 trees. So first one is already taken off. So in the next scenario, I can, since I am going with the 0.5 meter stages, again I can write down detail, but here between more than 1 meter but less than 1.5 meter. So I can put down the reference like this: B1, 2, and 2. So you can see this one is B1, 2, but this is the third scenario. And if you remember what kind of dimension we are getting in this taking of place, it should be in a number. So number 1, only 1 tree. Here you have 3 trees. Should be number 3. So to confirm that, I will again show you the SLS 573. Look at the reference in here. D1, 2, again 1. And in the next scenario, D1, 2.2. And you can see the unit is in numbers. It's pretty easy, right? So what is our next thing should be? What should be our next taking off? So once you remove over the site, once you prepare the site, in the next point you have to excavate the topsoil. What is the reason? We can clear off the humus soil type, right? It should always facilitate the plants, but in construction it might be a disadvantage. Having such weak layer of soil below our structure or the house, because eventually those vegetation is going to be disposed into much smaller particles. Then they might eventually create some voids, and there may be some structural failures, foundation failures. So we have to excavate also. Now in SLS 573, there's a exception in there. Still, they are not teaching this one, but it's not stated in the SLS 573 as well. When you excavate the topsoil, in the specifications, they already given. You have to excavate topsoil average depth of 150 millimeter. Actually, this one is okay. But what should be our area? What should be our area? Because excavating topsoil is calculated as a area measure. Should be excavated as an area measure. But what should be the reference point? It is also in the excavation D 2.1.1. So if I refer to the D.2, you can see D.2 excavating, D.1 topsoil for preservation, then D.1.1 average depth. It is 150 millimeters. Stockpiling method of disposal should be stated. If you remember, disposal is on site. Right? topsoil should be disposed as on-site. It is clearly stated in the specification. The third one. Look at the specification as well. We should be square meters. Now we have this problem. Now we have practically this problem. I will show you. I hope you can hear me properly. So let's say this is our site. Let's say it is let's say it's just for my easiness. I'll put my land like so. It is 40 meter by 40 meters. Now we clear all the clear vegetations. Now we have to come to the topsoil preservation or topsoil removal of the construction plan. And you can see in the plan, our plan is 20 meter by 20 meter. From external length, from external girth, it should be 20 meters by 20 meters. 20 meter by 20 meter. So this is from foundation, external foundation to external foundation, right? It is not the center line, but it is from, if I write it down like this, so these are, let's say these are the section of these points. This point and these points are section views of from the ground, right? So 20 meter is from this line to this line. Now, if you can imagine this one on your mind, if we have to remove topsoil of 150 millimeters from the ground level. So ground level is, you can see it is from starting from here. If I reduce 150 millimeters from the ground level, it is going to be already excavated like this. You can see this is our new reduced level, this red dotted line. Now we have a problem. Right? Even it is stated in the SLS 573, it is not a good practice to only clear off this area, right? Topsoil එක මෙතන විතරක් ඉවත් කරලා බෑ. But as a practice, we can either, you might learn this one in your A levels as well. From each of the external walls, either you can go for 3000 millimeters, which means from each wall, you can clear the topsoil up to 3 meters from each wall. Then you can see we are actually clearing of a large area rather than our site, rather than our construction plan. We are going much more, we are removing much more area. But it is either 3 meters or sometimes they are considering this one as 0.9 meters, which means 900 millimeters. So these are two practices. It is not stated in the SLS 573, but this should be remembered by you. I think it's better to go with the 3 meter one because it takes some time, but it's okay. let's say we will go with the 3 meter external diameter. Sorry, external lengths and widths. So in that case, you already know this should be in square meters. So what would be our topsoil removal area? So I can write it down like this. So this can be either write down as a waste calculation. So we have 20,000 in each side, and we have to add, you can see, add another 3,000, which means 3 meters. And for one side, there should be 2 times 3 meters. So for the horizontal length, for horizontals, actually there are, in one side, we are calculating an area actually. So what would be our value in here? For one side, 20,000 plus 6,000, it's going to be 26,000. So this is the same value for the vertical length, the vertical side as well, the width sides as well. It is again, this one is to the 20,000 plus we have to again another add 2 times 3,000. So it is again 26,000. So you can write down the base calculation somewhere in your description, and then how to put that one in the TDS sheet. I'll write down in the dimension column somewhere in here. So this is the times, dimension, and summing up. The summation in here. So for the dimension, I can write down the description. Right? The bottom point of the description, I can write down 26 multiplied by 26. Now you can put the value in the summation. Please write down the base calculation as well as the dimension column. Complete the dimension columns as well. I will give you 2 minutes for this one. So in here, the value should be somewhat differ. This should be 26 multiplied by 26, and there should be the corresponding value should be there in the sum in lab. And you can write down excavating topsoil for preservation average. So there are various abbreviations we are using. So it should be AVG, average depth 150 millimeter, commencing from ground level. So why we have to always stay where we are starting to dig, commencing from ground level. If you correctly refer the SLS 573, if you correctly look at the so you can see, I hope you can see the SLS 573. It's coming under the excavating to reduce levels. And you can see average depth stated if
less than 300 millimeter. So it is less than 300 millimeter. So we actually stated the depth as well. I think it's better to get both of them in the screen. I'll try to do that one, but just give me some time. Okay, now it is much clear, right? So here you can see excavating to reduce levels, average depth is stated. So we have stated the depth as well. Look at here. Here you can see excavating topsoil progression, average depth is stated. And if you go further in the SLS 573, in the same column, right? Actually, it is under the coverage rules, as I believe, in the excavation part. You can see in the supplementary information, commencing level. For every excavation, the commencing level of the excavation or filling should be stated. So where you are going to start the excavation. So in that case, I can write down commencing it from the ground level. So that the reference is D.21.1. Did you understand? All the commencing points should be there for each and every excavation as a supplementary information. Right? Which means in every chapter in excavation and earthwork, it is coming for the site preparation, as well as excavating, as well as item extra, breaking out existing materials. For everything, the starting commencing point, the commencing level should be stated. So that we learned so far. Then I can move to the next takeoff point. From the list, can you state what is the next taking off point? It should be once excavated topsoil. The third one is disposal of excavated material. Now you have excavated the site as well as the topsoil layer as well. Now what do we do with the soil after this one? So after the excavation, what we have to do? So that is also given under the SLS 573. Let's look at the disposal of excavated material. Look at any specifications regarding to that one. Any specifications? Actually, excavate topsoil, it should be disposal on site for reuse. So we have to dispose that one on site for reuse. Right? And all additional excavated material should be disposed off site, 4 kilometers from the excavation. So there are two conditions. Let's see how to respond to that, how to prepare our answers. So if I refer to the SLS 573, where you can find the disposal. So it is also under the section D, point 8. It is, you can see, section 8, disposal. So what type of disposal we are doing here? Is it surface water, groundwater, excavated material? We are doing excavated material. So disposal of excavated material, is it whether on-site or off-site? So in the first scenario, they say we have to do it on-site. So it is D8.3.2. And it should be in square, sorry, it should be a volume calculation. It should be a volume calculation. So how to do this one? How to get this volume now? We barely even get the center line as well. Right. So again, I'll go back to the taking off sheet. You can see there's a symbol. This one is known as the ending on symbol, the ampersand symbol, ending on. Disposal of excavated material on site for reuse. So this is our description, as I stated earlier in the SLS 573. You can see disposal of excavated material on site. Either there are some informations specify the location and the quantity of the bulk. There are such details, but I'll basically stick into the simplest version. Right. So in that case, now my problem occurs. What should be our unit for this one? How to get the cubic meters? Okay. Now, if we want the cubic meters, for those who cannot understand this one, I will draw that one on the board.
Now from the complete side, we have removed 26 by 26 meter layer of topsoil. And how do we get the volume? How do we calculate the volume? So we have the length and the width. What would be the height then? The height should be 150 millimeters, or it is 0.15 meters. So in that case, you can see later in the TDS sheet how this has been written down. So in theory, if you can imagine how this happened, I can write down this one using the green color. You can see from the existing ground level, we are reducing the level up to 150 millimeters. So what happened now? This layer of soil, this volume has to be removed. This green volume, there's no plinth wall yet, right? There's no plinth wall yet. So this green color layer should be calculated as in cubic meters. So the length and width we have, then for the depth, if you multiply it by the meters, 0.15, you can get the volume.
Now you can see disposal of excavated material on site for reuse D8 3 1.1 D8 3 1 again 0.1. So what we can do is that from the earlier value 20 by 26 multiplied by 26, here it should be corrected as 26 multiplied by 26 point. Actually, this should be in 2 decimal points. So what is the value of 26 multiplied by 26? It is 676. 676.00. So you can just multiply it in as a waste calculation, or otherwise you can write down this one in here as well. 26 multiplied by 26 multiplied by 0.15. Then you can get a value of 101.40. So this should be your answer. But what is the purpose of putting an ending sign on here? What is the purpose of putting an ending sign on here? So it is the same dimensions, right? You can see if you have the same dimension and if there's another description for the same dimensions, you can just, instead of writing down this description, sorry, instead of putting this dimensions, I can just clear off this part and I can just write down the ending sign and I can write down the description. That's it. And since this one and these two descriptions are related to the only these dimensions, this set of dimensions, I have to clearly draw I have to put some brackets for this one as well. So in that case, I can understand, okay, for these two descriptions, this is the set of dimension. This is the set of dimension. Right. Instead of calculating that one on the times in column, the dimension columns, you can put it in the descriptions as well, but it's okay, right? It saves time, but it is always in this scenario, I think it's best to put the values and remove this ending line as well as the bracket. Right? But both works, okay? Both of the methods are working. You might think this might be disrupting for our final BOQ, but it is not, because we are again from this TDS, looking at this TDS, we are actually preparing a abstract sheet as well. From the abstract sheet, we can calculate the final values, okay? This, if you multiply this value can be actually calculated from the abstract sheet. In this scenario, it is okay, right? So if we write down up to this point, we will take a small break, then we will move to the our next taking off point, excavating trenches. Okay. So we'll take a 10-minute break. We'll start at 10:27. Right, we'll continue the lecture. So did you find out the central line values and the internal values, internal wall values? So how to do this one? So there are easy methods, because since this one is a very simple building, it is very easy to calculate these values. You just want to have a look at the, first of all, you have to look at the plan and what kind of value you have given. You can see we can directly calculate the external width from the external lengths, right? But if it is internal length, again, we have to calculate the external length as well. And the second point I'm going to concern about is that what is the thickness of the brick wall, and what is the thickness of the this concrete bed, right? The bottom bed, what is the width? That is what I am concerning about, right? So if you can see in the plan, actually this one is a very special plan. You can see if you look at this line, actually this one is the external wall. This one is the internal wall. Simply, and typically in the exam as well as in different questions, they have always given the external wall length or internal wall length, right? But in this scenario, if you try to calculate this one, they have only given, actually, they have given the external length, external side of the trench. The green color represent the trench length, right? You can see it is the trench side. This side is actually the trench side. You can confirm that one. Usually it is given from the wall height, but in this scenario, they have given it from this side to the next side, right? Actually, this changed the center line calculation. Can anyone share what were your values of the center line and the internal girth? Can anyone share what you have got if you calculate those values?
Now, I hope you can see the board. So what they have given in here is the external trench line, right? But usually we are getting the wall thickness as in the most of the plans. But it is okay, however. When it comes to the center line, you can write down it should be in between the wall, right? So this red dotted line represents the center line. So how to calculate this center line length? So as a standard practice, you can write down, first considering the horizontal distances. So the length is 20,000. So this one can be written down in the description part as well as base calculation. Because when it comes to the excavating trenches, we have to always calculate the internal girth, external girth, and the center line, center girth. So if you take length and width, it is both 20,000. So you are left with 40,000 in each side, and you can see there are two sides like that, so it is going to be 80,000. What is this value? It is the external girth, but it is not at the actual external girth, because external girth is somewhat, we consider that one as from external wall side to external wall side. But in this scenario, we just assume that end of the excavation trench side, this is the external girth, but it is okay, right? So now how to calculate the center line girth? If the external girth is 80,000, you have to now reduce this part, right? Let's say, you have to deduct some parts actually. So deductions can be written down as capital D, simple D, like that, deduction. Now, as I told you earlier, when it comes to center line, calculating the center line girths, you have to only concern about two parts. What is the length and height of the building, and what is the width of the wall or width of this trench. So here, what is the width of the trench? I think this is the part you might calculate it wrong. So this width is this width. It is, since it is a trench, it is 600. So we have to reduce to get the center line length from the horizontal side, these two lengths. From the vertical side or from the width side, we have to reduce these two lines. So as in practice in your A levels as well, first you have to indicate what is the total width. It is 600. It is 600, and for one side, from one side, you have to actually not reduce the whole 600, but only half of the 600. So you have calculating a half, right? So you have to reduce the half of this section. And from one side, let's say for the horizontal side, you have to actually deduct two halves, this half and this half. Or otherwise, one can say, if you consider this section, if you consider this L section, you have to reduce this side as well as this side. Two parts from each L junction. Two parts from each L junction. And you can see there are 1, 2, 3, 4, 4 L junctions multiplied by 4. So as I told you earlier in the quantity survey, this line represents, it is a multiplication. So 4 multiplied by 2 multiplied by half multiplied by 600. So it's going to be how much? We have to deduct 2,400. 600 by half. For one side, it is 2 multiplied by 4. I have to deduct 2,400. So that gives us the center line girth or center line length. 8,000 by 2,400 is going to be 77,600. Actually, in this scenario, this is enough, but sometimes you have to, it is better to always calculate the internal girth as well at the same time. So if you reduce this same amount, again, what you can achieve? You can achieve this internal length. You have to just reduce the same size because we are considering half of the trench. So this is also half of the trench. So you can perform the same reduction, right? In that case, I can write down again. Okay, can someone confirm, can you see the board? I think for this time you are seeing the board, right? So below this calculation, I can again write down deduct the same value 2400. You can either show how that has been calculated. It is going to have with us 75,200. So these should be in the these should be written down as in your waste calculation. And when it comes to the trench excavation, what is the next thing? So you might remember we have to always calculate that term as a volume dimension. So this is the, if you want to get the volume out of this trench, you have to have your width, it is 600. Now from here, we have calculated the center line, right? So the width is always going with the center line. So you already have the center line. Center line, you have the width of the, trench. What else you have to have? You want the height, right? You want the height as the last field. So now what is the height of this trench? My question is it 1,200? So 1,200 means it is from the previous ground level. From the previous ground level to the bottom part is 1,200. But since we have done the topsoil excavation up to 150 millimeters, now it is actually reduced. So what is now our existing value? It is 1,200 reduced by 150. Now our height should be 1,050 millimeters. This should be your height. This should be your height. Now you might confuse this one with the exam. Always remember, once you do the topsoil preservation, you always reduce 150 millimeter. Now it is not the total height. You already reduce up to some level, right? I mean, that is the importance of writing down or drawing the exact thing happening in the site as well. This is for your easy reference. If you mess up with this one, you might have 3 values. You are getting 3 values wrong, right? Okay. So make sure to write that one, write that important fact as well. And you can write down either the waste calculation, which is also in the slides. I display the slide right now. Now in the slides, you can see how it has been calculated. The external girth, centerline girth, and the internal girth.
as well as we have deduct the reduced level as well. So this is a separate calculation. You should understand this part, okay? I'll show you why the reason to do that waste calculation in there as well, the trench depth separately, right? And another thing, center line, why we cannot use center line, why we cannot use the external girth for our excavation? What in most of the time you might see the external center line girth is the one using. We cannot use the external girth and internal girth. For this, there is some reason behind that. I'll draw that one again as well. The reason behind why we are using center line for all of our calculations most of the time, it is the correct reading. If you take the external girth, you might get the wrong values. I mean, the values may be overestimated. If you calculate with all the values with the internal girth, you might get a reduced value, but it is not the correct one. So center line is the most probably the midpoint or the correct value you have to consider. So I will explain that one with the next taking off. It is, what's the next taking off? It is we have done the site preparation, excavating topsoil, disposal, and the fourth one, excavating trenches, is the one we are going to do right now. Excavating trenches. I think you have already written down the values in here. If not, please write down at least the external girth, center line girth, and the internal girth, as well as the trench depth. It is as 1050. Quickly write down these three as well. So again, we are in the section D, excavation and earthwork. If you move to the second point, you can see this is the excavating part. It is in the column 2, excavating. Now, what would be our selection? Is it for topsoil preservation or to reduce level? So if you excavate a trench, it is not a topsoil, right? It is not a topsoil preservation. It comes under reduced level, comes under the reduced level. So excavating to reduce levels, there are two scenarios. Average depth is stated if less than 300 millimeter. So what is our new depth of the trench? If I ask, I share it in the whiteboard as well. What is our new depth? So earlier it was 1200. Earlier it was 1200. And under the topsoil preservation, actually we have removed 150 millimeter from the top. Now we only have to reduce the level from here to here. So our average depth is, I think we have calculated it as 150 millimeters, which means 1.05 meters. This one is in millimeters, right? So in this case, I have to go with D.2.2.2.2. If average depth more than 300 millimeters, then I have to calculate it as in cubic meters, right? You can see the difference. If it is less than that value, it can be calculated as a square meter. So what are the other details? So this is the most confusing point when it comes to the exam as well. I can see a lot of people are misguiding and miscalculating the same thing again and again, right? You have to always remember, you have to always reduce 150 millimeter because we have already reduced the level. Right. So that would be said. Again, move back to the TDS. Then you can write down excavating trenches width exceeding 300 millimeter, width exceeding 300 millimeter, actually the width is 600 millimeters, and total depth exceeding 1 meter, but not exceeding 2 meter, right? I think there should be a small correction with the trench excavation. Actually, I forgot to show you earlier. There's a trench. For the trench, there's another column as well, right? There's another row for the columns, a row for the trenches as well. So it is under the excavation and earthwork. Look at the left side column, the site preparation, excavating. Under the excavating, you can see topsoil to reduce levels, basement, pits, and trench width, and trench for at baffle. So you have to go with the trenches width more than 300 millimeter because our trench is 600 millimeter, right? So in that case, our reference is going to be changed, right? It is 2 D2.5. Again, you have three choices in here. Not exceeding 1 meter, not exceeding between 1 meter and 2 meter, and thereafter in 1 meter stages. So what is our height? So here they are talking about the height. So here they are talking about the height. So my height is going to be, actually it is 1.05 meters, right? So it is in between 1 meter and 2 meter. So it is stated we should be going with the second one, right? And that could be our answer. But for your information, let's say if it is more than 2 meters, if your trench is, let's say excavation is more than 2 meters, how to write that one in the TDS sheet? You can see in the third point, and thereafter in 1 meter stages, which means that you can write down in the dimension column like this. If it is, let's say it is 2.5 meters, then you can see the here the choices are formulated like this. Is it less than 0 to 1 meter, 1 to 2 meter? Again, 1 meter stage means 2 to 3. Then second one, 3 to 4, like that. So if I am talking about the 2.5 meter, 2.5 meter should be going with the third one. So it should be in the description, you should written down like this, exceeding 2 meter to 3 meter, like that in the description. But however, in our case, it is 1.05 meters. So that would be under the second one. Okay. If you got that point as well, I'll move back to the TDS sheet. There you have the description correct. Total depth exceeding 1 meter but not exceeding 2 meter, commencing from 150 below ground level. Now, this is also important that I told you earlier in the excavation section. As a supplementary information, you should always write down where you commence in the excavation. So it is commencing from 150 millimeter below ground level. And you can see the reference as well. Now, now I come to my point where you can see it is in cubic meters. You should have the width, the height, as well as the length, center line length. Why we always have to write the center line value? As I told you, I will explain that one. For that, I will move back to the whiteboard. So as I explained earlier, so this was our original trench, right? From the ground level to it was from the ground level it was 1.2 meter, but actually under the first takeoff we have reduced it to 150 meter from the ground level. So this has been already excavated. Now the blue line is our new reduced level. So this size is going to be 1.05 meters. Why we have to use the center line? Let's see. Let's actually assume that this is our
external girth. This is our external girth, and this is the trench plan. Okay, this is the trench plan. So what is the external girth? It is 80,000 or 80 meters. It is the length. It's a parameter. Right? So if you multiply in order to calculate the volume in the dimension section, 80 in the TDS sheets, you have to always follow this rule. You have to write down the length, then width, then you can write down either height or a depth. Height or a depth. So I'm going with the length. Then my width is going to be how much? It is 600. So which means 0.60. So what is going to be my height or the depth of the trench? It is going to be 1.05. So you can see if you multiply each of these together, you might have a larger value under the external girth. You might have less than that value in the center girth, or you might have a smallest value in the internal girth. So how you can imagine this one happen? Let's write down it like this. So in the external girth scenario, I can write that one down like this. So this is my external girth. So I am following 600 millimeter trench like this. I am following 600 millimeter trench like this. So this is not even our trench actually. It is further above the trench. So I will start from this section. So remember, this is a plan view. Imagine what happening in here when you excavate the trench along the external girth. Starting from here, our width is 0.6, height is 1.05. Starting from here, you are going to this point, right? Then from there, since you have calculated the whole external girth, you are again coming from this point, again take another 0.6 width like this in this red color, come to this point. You are excavating through this line. Thereafter, again you are getting 0.6 width and come to the next point. Now you can see the plan is correct, right? What I have shown you is also correct. So along the external girth, I am going. I am excavating. So you can see there are the same point. You can see if I zoom up to this point, you can zoom in here. I'll zoom manually. Check whether from UI screen you can zoom it up to this part. So you can see the same point again and again 2 times. You have actually excavated this part. So that is going to be wrong, right? The same point 4 times has been excavated, as well as so not only that, actually we are off the grid. We are off the grid of our original trench, right? So these blue lines are the original trench, but we are excavating further apart. You can see it is this much. You can see it, you can observe it on all the sides. So this is so that's why we cannot get, actually you can get a higher value if you use the external girth, but it is going to be cost us more, and that's not our correct value as well, right?
So if you understand up to that point, so the same thing happened if you follow the internal girth. So this is going to be our internal girth, and you can see you can get a much smaller value. But the correct one is actually in the waste calculation, we have deduct these 4 parts. You might remember the whole width is 600 in trench multiplied by half point. For each side, there are 2 values to be multiplied, and there are 4 junctions multiplied by 4. Then you can only get the exact value. In the center line, you are excavating, calculating this part. So you might get the correct value. So I hope you can understand that point. Please note any important fact if you are going to forgot about that part. Otherwise, I will move back to the taking off sheet. Okay. So you can write down the values. We are using the center line and the width and the height. You might get a value of this 48.89. It should be in cubic meters. And there's an ending on as well for this one, which means so the same calculation in here should adjusted to this description as well. That is mean by ending. So what is our next taking off point after the earthwork support? Sorry. Excavate in trenches, then we have to backfill into trenches. Do we have to backfill the trenches? Right. Look at the specifications. So once you excavate the trench, there are a lot of 48 cubic meters of soil is going to be in the site. All additional excavated material to be disposed off site 4 kilometers from the excavation. Okay, so with that in mind, we'll again move back to our description. So where this backfilling to excavation average thickness 1.05 with excavated material obtained on site commencing from 150 millimeter below ground level. Where should be this disposal goes? It should be going with the SLS 573 under the earthwork. Look at see in the section D, if you go to the disposal part, it is under the column. It's under the row of filling, right? So we have to fill to excavate, and we have to state the average thickness. And it should be on site as well. We have to fill the excavation as well once we do the trench excavation. So how we are going to write that one down? You can see the reference is 9.1.1.1. And since it is also in the excavation, we have to always state the commencing level as well. Again, moving back to the TDS sheet. You can see in here, backfill into excavation, average thickness of the thickness of in the whiteboard, you can see it is now 1.05 or 1015 millimeters. With excavated material obtained on site, commencing from the commencing point. Since we are backfilling, right? Since we are backfilling, why we need to backfill? Now you might wonder why we need to backfill this one. So when we excavate, we cannot actually excavate up to the most nearest value. I mean 1050 millimeter, we cannot achieve that exact value always. Okay. So in that case, we have to again do some backfilling as well, right? So backfilling is started from 150 millimeter below ground level. And it is also, I forgot to show you, you can see the filling should be always, the filling should also come as a cubic meter quantity. You can see this cubic meter should be relevant to this column. So filling should be in cubic meters as well. So since we have to use the same value, I can just write down ending on the symbol, the ending on symbol, the ampersand symbol, you might remember, and you can put the bracket to these two descriptions because we are referring one set of dimensions. Then we can move to the next point. Now I am not going to go for the taking off list. You might, if you write down your take off list, the next one is about the earthwork support, right? Earthwork support. Now, so when it comes to earthwork support, what are the earthwork supports? You already know. They are formworks, right? To stop collapsing soil into the trenches, we have to put earthwork supports, right? So let's say we are using formworks, the wood formworks. Wood though is still most probably we are using the wood formworks. So where we can find out about this earthwork, the first point, and how to calculate the formwork. You can see it is obviously given as a square meter. So you can see it is in a it is considered as a area dimension. So how to calculate this formwork area of our trenches, and which part of the trench should be supported? Right now, there are a lot of questions, right? Okay. Now let's first move to the SLS 573. So you can find about this earthwork support. It is also in the excavation section D under the row 7. Now, if I ask what is my depth of the trench, this is the next consideration. Is it below 1 meter, or is it below 2 meters, or it is below 3 meters, 4 meters, like that? So what is going to be our value? So if you remember, it is actually less than the trench height is actually now from the original height is 1.2 meters. But once we reduce the topsoil, it is 1.05 meters. So since our depth is 1.05, so earthwork support total depth less than 2 meters. The next point is, it is about the width. Distance between opposing faces. What is mean by opposing faces? So these are the opposing faces distance, which means it is the simply with the width. It is, what's the width? It is 600 millimeter. So again, we are going with the first one. Distance between it is less than 2 meters, right? And you can see in the measurement rules, earthwork support is measured to the depth of all faces, right? And what else? Right. And my next question is, to where we are going to place these formworks? Since you all know where to put this all the formworks in red color, I can write down these two faces, right? For only these two faces, we are going to put the formwork, not to the bottom. Okay, not to the bottom. So now we have to calculate. This is the external, let's say this is the external trench line and this is the internal trench line. So for separately we have to calculate the internal wall and the external wall formwork area, which means this area and internal this area formwork area completely. You can do this one with 2 dimensions. Let's move to the TDS sheet again. So with that reference in mind, I can write down the description like this: earthwork support total depth not exceeding 2 meters and distance between opposing faces not exceeding 2 meters, 7 to 1. So look at this one. And there should be correction in this scenario as well. I will explain that one. So in the right side figure, as I drawn right now. So what is this length? So if you multiply this length by the height, what you can have? The area of the external formwork, right? So what is the length? So the length is 80 meters. Or you might remember external girth. If you look at the board, external girth is 80,000. So it is our external girth. So what about our internal girth? The internal girth, if you reduce 2000, I think it is 2400. So sorry, it is 4800 from total external girth. You can get this internal girth, internal trench line wall distance. It has 75.20. So it was in the waste calculation as well. And what is the height? Why in this case? Why in this question? Why there are 2 values? Here it is 1.2, but here it is 1.05. Why it has been changed right now? Now, in our scenario, this should be actually 1.05, right? You already know this one. This is also 1.05. Right? Not 1.20. This should be corrected as 1.05, right? Because it is already excavated. Why? But my question is why in this question they have considered this value. So I will explain that one as well.
So in the previous description, there were two values. So we'll see what happened in here and why our calculation is somewhat different from the original one. So in the first scenario, I told you earlier, in the SLS 573, there is no theory as when you clear off the topsoil for preservation, you just have to observe the site. I mean, according to the plan. Let's say you just have to follow 20 meter by 20 meter. But I told you that if something like this happen, what happened is that when you preserve the topsoil, the internal side is going to be reduced by 150 millimeter. If you only remove the topsoil for preservation, only considering this square, only considering the original plan, what happened is that when it comes to the section view of one foundation, section view of the foundation, this is a plan, this is a section, let's say it's six. So what happened is that this side is going to be reduced, but the other side is going to be much higher in value. So it is going to be somewhat like this. You can see one side is larger than the other side. That's why this is the external face and this is the internal face of our trench. That's why in the original calculation, for the external part, they have multiplied the center line by this original height. It is 1.2 meters, but in the internal side, since it has been reduced up to 150 millimeters, it happened to be 0.5 meters. That's why in the original calculation there were two values. But what I have told you earlier, as I told you earlier, as a practice, we are always clearing 3 meters from all the sides of the wall, or either it is 0.9 meters from all the sides of the external wall. Since I clear off all these parts, what happened is that the external trench has already been excavated. So these two become in the same level. That's why in my calculation, this is going to be again 1.05. Can you understand the correction? So if you have any problems, please let me know. You can write down this figure. You can zoom it if you cannot see. And you can take 2 minutes to write down this point. Then we'll please write down the description as well as the dimensions with the lecture. From 2 minutes, we will start continuing the lecture. Okay.
Now the description can be written down as earthwork support. Description can be written down as earthwork support, total depth not exceeding 2 meters and distance between opposing faces not exceeding 2 meters. And for the external walls in a separate calculation and for the internal walls separate calculation. And in our scenario, this should be again 1.05 instead of 1.20. And this should be also corrected, right? And you can put a bracket to the same description as well. Right. Continuing on, what is our next takeoff point? So we are up to point 6. Second one is compacting bottom of excavations. And the 8th one is disposal of surface water before putting concrete foundation. Before putting concrete foundation, we have to do 2 points: compaction and disposal. So how to do the compaction? Actually, even though if I look at the specifications, there were no such details, right? There were no such details about surface treatment or anything regarding compaction. Now, so I might have a issue now, right? I might have an issue. I don't know, in the specification even they asked to take off the surface compaction. They are not even give us the what kind of equipment, what kind of machinery I have to use for that same purpose. So in that case, we can put that question in the core sheet. So we use the core sheet. Actually, this core sheet is another document. The purpose of the core sheet or this core document is to, in case of unclear detail or in case of unclear drawing or in case of less amount of information in these specifications, you can ask that question in the core sheet. So I'll move to the core sheet now, how to prepare that one, what is the structure. And remember, in the exam, there may be some core sheet you have to prepare. Okay, there may be some core sheet you have to prepare because sometimes you have to assume the values and do the calculation, or otherwise you have to raise a core sheet like this. So this is the structure core sheet. What is the name of a project? So this is the name of the architect or engineer. And this should be your name of the quantity survey. So quantity survey is the person who is doing the taking off, and he is doing this one looking at the drawings. Who's the person drawing these specifications and drawings? Either by architect or an engineer. So in order to find out, I mean, for a in a audit personnel, he might want to find who's the person raising this core sheet and who is the person answering this core sheet. So the person of the raising the core sheet always a key quantity surveyor, and the person who is giving answers is going to be the architecture or engineer. So their name should be with the along with the project should be there. Then item number, date, the query. Query means the meaning of the query is any question, raising any question, and the date and the answer. So there are 2 dates. Why there are 2 dates? So when you raise the query, it is these dates. This is filled up with by, this is filled by the quantity survey. These 2 columns, these 3 columns. The answer with the along that date will be filled up by the architecture or engineer. So you can see in the first item in 2015 March, date to 10, queries specify kind and quality of film material for site preparation. You might remember for site preparation, we have to fill. So what is that film material? You have to specify the kind. Okay. So even though he raised that question, the same day he get the answer by the architect. He just write down the imported soil. He can put the date as well. Right. And there's another question. You can write down the date, area, site preparation, but sometimes it takes a considerable amount of time to get the answer. Okay. Even though we are not going to stop preparing the taking off list. Instead, we are going to keep going. Right. Third one, method of compaction of bottom of trenches, top of hardcore. You can see this is my question. Now in the compaction, what is the method? Now I have the question. So I am going to write down it like this. It should be method, not method. Method of compaction of bottom of trenches. How they have given the answer with 1 ton roller. This is the machinery. So with that in mind, in the exam, there may be some lesser information. So if they have, let's say, if we don't have certain information, you can either assume the value or you can just write down in the query. Okay. In the question, you might have to press this query sheet as well. Okay. So once I think you have got the idea here. So I can write down surface treatment compaction of bottom of excavation with 1 ton roller. So it is going to be 77.60. It is the center line multiplied by what is this 0.60 mean? It is the so here center line multiplied by width of the trench. It is this much area. Right? It is no, actually it is not has been stated in the SLS 573, but it can be get as a taken off as well. It is also a pricing point, right? It is also a pricing point. And if you actually in more scenarios, you might going to face up you might pass the water level as well. So in that case, you might have a lot of water collecting to the trenches daily. So you have to, when it comes to the concrete pouring, you have to remove all the surface water. So disposal of surface water, it is actually an item. So where to find that one on the SLS 573? If you go to the excavation 8th row, so here you can see excavation and earthwork disposal of the surface water or groundwater. What is the difference between groundwater and surface water? If it is from rain, it is going to be surface water. If it is from the water level, it is considered as ground level. So in our scenario, what is our section? It is the surface water. Let's say after 2 or 3 days of raining, the trenches are filled with surface water. Then I would probably go with the surface water. Disposal of surface water. Consider it as item. Surface water. You got the definition rule in here. Surface water is water on the surface of site and the excavation. So it defined as the value as well. What is defined? The definition rule also given what to be considered, even if you forgot the things. So with that in mind, I'll move back to the TDS sheet. Then I can write down it just as an item. So this item can be transferred into the abstract sheet. So we conclude all these values according to the section wise. I mean, you can see we are referring to, still we are referring to excavation section, right? You can see starting from D, there are a certain amount of excavation. You can see this one also, there are a lot of excavation section taken off lists. So we can conclude all things to one. So that's what happened in the abstract sheet. We'll do abstract sheet preparation as well for the same example. Then moving on to the next part, that would be the concrete foundation, right? Concrete foundation. So before moving to concrete foundation, I want to again remember what is happening on the ground right now. What is happening on the ground right now? You only have this part, right? Am I correct? You only have so you only have now 1.05 French, right? This is the French you are going to have right now. Always update with the site conditions. It will help to have the correct taken off list and the BOQ preparation, abstract sheets, score sheets as well. So we have to put concrete up to certain height. So if you write down the foundation section, if I remember, this should be 400 millimeters. I'll take that one. So here you can see the height of the trench is 400, right? The concrete foundation should be 400 in height. Width is 600, height is 400 millimeters. Then without taking time, you can go for the description. Obviously, in the specification, look at the specification as well. So you can see obviously it is a mass concrete. And if you follow off the specification, concrete 1 to 2 to 4, 40 millimeter maximum size aggregate. So without using the reinforcement, which is going to be a mass concrete, not a reinforced concrete foundation. With this one in mind, we can write down the description. Mass concrete strip foundation 1 to 2 to 4, the mix ratio and the maximum aggregate size. Poured into concrete. Why do we have to write down this? Poured into concrete. Poured into ground, sorry. Poured into ground. You can see it is also in previous calculations we talk about this one. It is in cubic meters always, so we always have to use the internal girth for this one. And what is our width? I told you earlier, length, width, it is 0.6, and the height now it is 0.4. You can get this value. But what happened? Where do we getting this poured into concrete? In the description. So you can see this one under the concrete works. There you have to go for the F section. I hope you can see the screen. So we are in the section F, concrete works. There I will go for the first columns. So I will choose the foundation. So what kind of foundation? Is it a screed one? No, screed one is a much smaller in thickness. 400 millimeter is much larger, you know. So it is going to be a strip foundation. It is not a column base or a curb or a basement wall or a raft. It is just a strip foundation, the simplest foundation. Foundation is strip foundation, and you have two choices again. Is it mass concrete or reinforced concrete? Since there's no clue about rebars, I'll go for the mass concrete. And if you go for the mass concrete, don't confuse with this one. It shouldn't be a number. Actually, since I am following this column, following this row, right? You can see I am following this row. Okay, the strip one. So my value is going to be, calculation is going to be from cubic meters. And again, this cubic meter also happen to have these two included. Curved radii, it is not a curve, so there's no curved points. And any other shapes, let's say you can say rectangular shape like that. Let's look at other details as well. Right, you can see in the supplementary information poured into ground or into formwork. You have to state that one, right? So that's the referencing of SLS 573 in the correct way. You have to put all the details into the description. Then only you can get the full marks. So with that in mind, I can write down the details like this. Mass concrete is a foundation, and you can you can see it is correctly calculated. After the description, you can see it is dimensions are put it in the correct level, and there's an ending on, and we have to deduct filling to excavation. What is mean by ABD? Here ABD means as above described, right? As above described. And add means addition, disposal of excavated material off-site 4 kilometers away from site. Now, once you pour the concrete, you have to, sometimes you have to fill the excavation as above described, and you have to dispose the excavated material offset. Actually, this disposal part is already given, right? So the same value should be identified, and you can see ending on represent the same set of dimensions for both scenarios. Then we can move to the brick wall. Now, before moving to the brick wall, so if you look at the site, what we do have now in the board, you can see in the below figure. Now the concrete has been poured up to 400 millimeters. So what is the length of the brick wall then? What should be the length of the brick wall now? So for that, let's go for the initial drawing. So can you identify what is the length? What should be the length or the height of the brick wall? So it should be up to this point, okay? It should be from this point to this point. This should be the height. So far we have completed. So far we have completed from the ground level. We have excavated 150 millimeters. Then this is our trench now, right? Actually, we have backfilled some of the soil. We have backfilled some of the soil, right? Now we have to prepare up to this height of a brick wall, right? So what is the height now? How to calculate the height? Now remember, from the ground level to the this height is it is 1.2 meter, okay? 1.2 or 1200 millimeters. So how to get this height? You can see actually above the ground level there is another height achieved by the brick wall, but it is not given in here. It is not given in here. We don't know the height from ground level to here. Otherwise, we can easily find out the height, right? In this case, I think I have to assume the value, assume this height. This is small height to be assumed. Let's say it is 150. Again, let's say we have to increase the height by 150 again millimeters to top side. Then what would be our brick wall height? Then I can write down the total height is 1.2 plus in meters, 0.15. Right, this is the total height of the from the reduced level or from the bottom level to the top of the brick wall, and I have to now reduce this part. I have to reduce from here to here this length. So what is this length? So again, I have to assume certain information because from here to here, the value is not given. Sorry, I forgot to earlier told you that from here to here, we have from the original ground level, we have excavated 150 millimeter. Right? But we actually don't know what is the, we can actually find out height from here to here as well. Right? Height from here to here, it is very easy. This height 1.2 minus 150. Sorry, 1200 minus 150 minus 400, you can get this value. Then adding this value and again 150, and again you have to find this height. It is again 150. If you reduce these three heights from the total height, if you reduce these three heights, sorry, I think it's I think we don't want to decrease those heights, right? We can just get it by, if you calculate the total height from here to here, and you just have to reduce the width of the, sorry, the height of the foundation. 1.2, it is going to be, this side is going to be 1.2 plus 0.15. We assume that from here to here it is also 1.05. This one is not the correct one. This is 150. Then if you subtract 400 millimeters, then you can get the brick wall height. Okay. So if I move back to the specifications, under the bricks, they have given engineering bricks and standard size and what is the bond to use, as well as the mortar. So with that in mind, I can write down the description like this. Sorry, I can do the calculation first. Okay, I'm sorry. I can do the calculation now. What is the total trench depth? It was total trench depth was 1.2 meters. So what is the foundation? Foundation cost up to concrete foundation was around 400 millimeters. This one is 1.2. 400 millimeters already here. So the remaining part is 800 millimeters. So this remaining height is 800 millimeters. So as I told you earlier, we have to assume a value because the brick wall is going above the brick wall is going above the ground level. So we have to assume this height as 150 millimeter, right? So if you add 800 to 150, you might get a brick wall height of 950 millimeters. So if you use that one with the center line, if you multiply that one with the center line, you can get the brick wall area, not the brick wall. Actually, this one is the plinth wall. You can get the brick wall area. So brick wall can be found out in the section G. Before going to that, look at the description. The brick wall, 250 millimeter thickness, and it is actually vertical brick wall. In engineering block and all the other specifications, English bond, cement sand mortar, and you can get the values. Now let's move to the G.1. Let's move to the section G. So it is about brickwork and block work, section G. So we are constructing walls. What is the thickness of the wall? It is stated. Is it vertical or battering or tapering one? It's a vertical wall. Then it should be given in square meters. That's why I have to multiply center line by the multiplying with what? Center line by the height of the wall. So it is also a solid wall, right? Because we are using the English bond. So you have to, what else we have to provide? You have to, as supplementary information, you should provide kind, quality, and size of the blocks that we have stated. What is the type of the bond, English bond, composition and mix of mortar, and any type of pointing, if any, like that. So it is section G 0.1, 0.1, 0.1, like that. So that's all